on today's lecture, we are going to solve some numerical based on optics. So, numericals. Alright. The question says two thin lenses, two thin convex lenses, convex lenses having focal length, how much? 5 centimeter given and 2 centimeter are coaxial and separated by a distance of 3 centimeter. Find the equivalent focal length. Find the equivalent focal length and the positions of principal points. So question says that we have given two thin convex lenses having focal length of 5 centimeter and 2 centimeter are coaxial. That means are aligned in a principal axis. This is a convex lens of 5 centimeter. This is convex lens of 2 centimeter, and the separation between this is for 5 centimeter. This is for 2 centimeter. Separated by a distance 3 centimeter. So the separation between them is 3 centimeter. All right. See, this is L1. This is L2. Find the equivalent focal length and the position of the principal points. Good. So if you remember, we knew that the equivalent focal length can be written as 1 upon f1 plus 1 upon f2 minus of d of f1 f2. From the question it is very clearly given. Our first focal length is 5 centimeter and our second focal length is 2 centimeter. Good. And the separation between them, d is the separation between them is 3 centimeter given. So I can find the equivalent focal length. So the equivalent focal length is 1 upon f1 plus 1 upon f2 minus d upon f1 f2. So 1 upon f1 is 1 upon 5 plus 1 upon 2 minus d is 3 into 5 into 2. So this will give me how much? 1 upon 5 plus 1 upon 2 minus 3 upon 10. So on taking LCM, this will give me 10, 2, 5 minus 3. So this is 7 minus 4 upon 10. Alright, so the equivalent focal length is 10 upon 4. So this is something 2.5 centimeter. So the equivalent focal length is 2.5 centimeter. If you remember our principal points are alpha, we denoted by alpha, so alpha can be written as plus of d f upon f2. So d is here 3, equivalent focal length is 2.5, f2 is your 2. So this is something how plus of 3.75 centimeter. Good. First focal point, principal point. Second principal point can be denoted as by beta. So this is minus d of f upon f1. So this is minus 3 into 2.5 upon your f1 is your 5 here. So this is minus of 1.5 centimeter. So if any question says, if you have the focal length given and the separation between them is given and say the find the focal length at principal position points, so you can use this formula, which is for equivalent focal length Right? And for the principal point, just memorize these four. First principal point is your df1 upon f2, and this is beta. All right, let's take another question. All right, a thin thin converging lens and a thin diverging lens are placed coaxially in air at a distance at a, of 5 centimeter. Question says a thin converging lens and a thin diverging lens are placed coaxially in air at a distance of 5 centimeter. If the focal length if the focal length of each lens is 10 centimeter, find for the combination A, you have to the focal length, B, the power, C, position of the principal points. Position of the principal points. Good. So we have f1 is 10 centimeter. Why? The question says that if the focal length of each lenses are of 10 centimeter. So, but one is converging, another is diverging. So this is minus 10 centimeter. Good. And the separation between them is 5 centimeter. This is also given. So for the equivalent focal length, we already discussed earlier. So this is 1 upon f is equals to 1 upon f plus 1 upon f2 minus d of f1, f2. We have given f1, f2 and d. Just now substitute the value. This is 1 upon 10. This is minus 1 upon 10 minus d upon 10 multiplied minus 10. Good. This cancel out. Here we have minus 5 upon minus gives me plus. So this is 100. So 1 upon f. So f becomes 100 upon 5. So the equivalent focal length is 20 centimeter plus of 20 centimeter. Equivalent focal length. Right. Our second point is this is A. B, power is equals to 1 upon f. Alright. So our 1 upon f becomes 1 upon f m, say fm. So fm becomes 20 upon 100. So this becomes 0.2 meter. Alright. So power becomes 1 upon 0.2. That means plus 5 diopter. Unit of power is diopter. Alright. Now in the third term, it says principal points. So the principal points are alpha. Alpha is already d1 plus f upon f1. Sorry, f2. Good. So d is your 5. Equivalent is 20. And f2 is your minus 10. So this will give me minus 10 centimeters. So alpha is at minus 10 centimeter, first principal point. Second principal point beta is your d f upon negative of d over f1. So this is 5 into 20 upon minus of 10. So this is again minus 10 centimeters. So beta is again minus 10 centimeters. So alpha and beta are the principal points and power. So all the three things we had already: focal length, power, and position of principal point alpha and beta. So this is how we can solve the numericals. So just go through the question properly. Then after see what things are given and just remind the formalism, and then you can calculate easily. So this is how you calculate the numerical based on optics. All right. Thank you.